Next sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the session for your own security reasons. All right. Oh, Audrey, you live really close to Disneyland. Is that what you're saying? Yeah, my old partner teacher actually lives really close to Disneyland as well. Oh, she lived really close to Disneyland. So yeah, she got to see the fireworks every night, which was super cool. Kind of loud, I guess. All right. At this point, everyone, go ahead and open up your attendance ticket. Give me a green check once you have it open. Passwords in the chat box. So waiting on green checks from, let's see here, Adrian, Ariana, Brianna, Dalen, Dolly, Libby, Jeremy, Johnny, Kim, Michael, and Ty. Make sure I get your green checks. I know fireworks can definitely be alarming, right? July 4th around here gets super noisy. Okay, so we have 11 days left of quarter number one. Starting on Monday, guys, we will have 10 days left. It's the 10-day countdown. Oh my gosh, so exciting. Yeah, it's Kahoot Day. Yes. So today we do have a game day. We're going to play Kahoot. We're going to actually do the review while we're doing the Kahoot, just like the does this make sense question. So I'm not going to actually review very much beforehand, just because I want us to try to get through an entire game. I feel like oftentimes we have to end a little bit early. So let's try to get through an entire game today, right? Cool. Okay, so we've been talking about waves. We've talked about the properties of waves, the effects of waves, the different kinds of them, the factors that influence them. We talked a whole bunch about vocabulary, right? Frequency, wavelength, pitch, amplitude, crest, trough, blah, 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 blah. So many of them. And we did not review the Doppler effect on yesterday, so we're going to review the Doppler effect today. Okay, so that being said, let's catch us up talking about the Doppler effect, which is kind of funny because the Doppler effect kind of has to do with the fact that waves have a hard time catching up, sound waves, because sound waves travel slowly, remember? Okay, so let's go ahead. Sorry, I need to actually open this up so I can get the link really quick to this GIF that I need. But taking a look at this, guys, so remember that, give me a second. Okay, so the Doppler effect is a change in pitch due to a sound's source moving towards or away from you. So depending on if a sound is coming towards you or if it is moving away from you, it's going to sound differently, and that's the Doppler effect. So let me prove this to you, because you might be like, I don't know about that, Mrs. Larkin. That sounds like a little bit like magic to me. So I'm going to prove this to you. Let me go ahead and grab this link. I'm going to share it with you on the whiteboard. It's 20 seconds, super fast, and also in the chat box. So here it is. Green checks when you finish listening to it. Ariana, make sure you turn your volume down. It's a loud one. All right, cool, guys. What did you observe? Tell me in the chat box. What did you observe as the fire truck was coming towards you and as it was moving away from you? So towards you, you saw it driving towards you, and then you saw it drive away from you. What did you notice about the sound? I mean, it was definitely loud the entire time. I don't know if it was necessary. It definitely got louder as it passed you, right? But what about the pitch of it? Yes. Okay, so Ty, it's in the chat box if you need it as well. So you can click on it in the chat box as well. Yeah, so as it was coming towards you, right, the pitch was really high. Smiley faces, if that makes sense, right? Remember we talked about high pitch is more like a female's voice, low pitch is more like a male's voice. And then as it passed you, did you guys hear the change? Did you hear the change as it passed you? Yes, it went much lower pitched as it went past you. So this is exactly what the Doppler effect is. And I guarantee you, you have heard the Doppler effect so many times in your life, and you might have just not realized that that's what that was. So here's what happens. When a sound is moving towards you, The sound waves, remember, sound waves can only travel so fast. And since the object is moving towards you, it actually pushes the sound waves closer together, which means if they're closer together, you can see that makes a much higher frequency wave. And we've learned that high frequency means high pitch. Smiley faces if you guys see that on this diagram right here. Okay, we can actually see right here that these lines are much closer. These sound waves are much closer. Awesome. Now, as the ambulance moves away from you, so when it passed us, it started moving away from us, we can see, again, sound waves are slow. And so they have a hard time catching up to the ambulance, and so they slow down a bunch. And as they do that, they are spreading out, which means we have a lower frequency, and that makes a lower pitch. Smiley faces if that makes sense. So a low frequency, meaning a lower pitch, it sounds much lower. Excellent. So just in case you're not exactly sure what this diagram is showing you, I'm going to go ahead and actually show you a GIF of it. So let me grab the link to this. All right, so let's put it up on the whiteboard for you, also in the chat box. Okay. All right, so what you guys can see is that source, which was the fire truck, is moving towards the observer. As it moves towards the observer, you can notice that those lines are really close. Once it moves past the observer, you can see now the lines for that observer are really, really far apart. Smiley faces if that makes a little bit more sense. Why the sound changes as soon as it passes you. Okay, because literally sound waves are slow. They're slow, so this is what is happening. Excellent, cool. Okay, this is number 1 in your attendance ticket. Give me a green check when you have it saved. I'm going to give you guys 45 seconds. It's a bit of a long one. If you need to, take a picture. Green checks when you have numero uno saved. Just waiting on a few more green checks. I love all the green checks I see so far. You guys are great. So go ahead, give me a green check. Ciara, Dalen, Dolly, Haley, Jasmine, and Ty. Let me know that you have number 1 finished. Or if you are having trouble with the attendance ticket, just take a picture and give me a green check when you have a picture, so you have it saved for later. Looking good. All right, guys, so here we go. Again, I'm not going to review the actual unit beforehand. What we're going to do is we're just going to go ahead and start our game. And throughout our game, I do have the review slides in it, so we can make sure that we understand this unit. Smiley faces if you understand what's happening. Okay, so just do your best, right? I totally understand that it might not be entirely fresh in your mind because some of it is stuff we learned at the beginning of the week. So just do your best because extra credit is based only on whether or not you participate. Okay, so don't judge yourself too harshly if you don't remember something and you get it wrong. It's totally fine. That is how we learn, right? Actually, you learn better when you make mistakes, okay? If you always get everything right, nothing really ever sticks out in your mind, right? When you get something wrong, you remember that feeling of getting it wrong. And because of that, your mind is able to better adapt and better remember that feeling of like, oh, I got it wrong once, but then I figured out what was the right answer, and that made me feel much better, right? You get a burst of dopamine once you figure it out. And that helps to make connections in your mind and help you learn. Smiley faces if that makes sense. Okay, so it's good to make mistakes and correct them because that helps us to learn even better. Okay, so don't worry if you make a mistake. It's totally fine. No one's judging you for it, okay? All right, so what we're going to do, go to kahoot.it either on your phone or on a browser. We're going to enter the game pin as soon as I start the game. Make sure you enter your first name and last initial. Make sure that I know who you are because if I don't and if I have to try to figure it out, I'm not going to give you your extra credit. So just make sure you make it easy for me to figure out who you are. If anyone needs a private chat, just double click on my name and then that will open up a private chat for you, okay? So yeah, Dolly, double click on my name. That'll open up a private chat and that's where your answers go. Just make sure you don't put it in the main chat because that's where people are reading your stuff, okay? And then we'll be ready to play, okay? So let me go ahead. I'm going to get our game started. So let me open it up. Give me a smiley face if you are ready to rumble here. Sorry guys, hold on. Let's try that again. Oh yeah, Dolly. That is how you do a private chat. Yeah. You should really only do it with your teachers though. If you do it with your friends, the teacher might take away your chat privileges if you're not staying focused. So just a warning. All right. All right guys, so let me go ahead. I'm going to share my Google with you. Give me a second. All right, here we go. Sharing this with you. All right, smiley faces, guys, if you can see my screen up here. Thank you for being patient. Looking good. All right, so let me see. Let me see my settings are all good. Good, 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 good. and love it. All right, so it's going to load, and then we will see the pin in just a second. Give it a few moments. Here we go. Here is your pin, 7240270. 0270, yeah. Go ahead, join on the whiteboard, please. I should see your name popping up here. Awesome. Thank you, Edgar. Thank you, Libby. Thank you, Audrey, Brianna. Oh, there we go. The names are flooding in. I love it. There we go. Remember, just do your best today. Just get your extra credit. Remember, you do need to answer most of the questions. I understand if you accidentally miss a few of them because it goes by too fast for you, but if you only answer like one question, you don't get extra credit for that. Be real, guys. Come on. Awesome. Just waiting on a few more people. Let's make sure we got everyone in here. Give you about another 10 seconds. You can always join a little bit later. The pin and stuff will be up here. But again, if you wait till the last moment to join, you don't get extra credit. Make sure you participate. Looking good, guys. All right, let's go ahead and get started. So, are we ready? Let's go. Okay, the purpose of waves is to transfer what? Purpose of waves is to transfer what? This is kind of a tricky one. This is literally the first point we went over in this unit. 10 seconds left. Remember, just guess if you're not sure. So you get your extra credit. Remember, it doesn't matter if it's incorrect. We'll correct it later. But you won't get your extra credit if you're not answering. Awesome. Thank you, Siva. I see yours. Dolly, make sure I'm getting your answers as well. All right, looking good. All right, yes, the answer here is energy. Yes, the purpose of waves is to transfer energy. No matter what type of wave it is all transferring energy. Excellent. All right, here we go. Livy in the lead, Edgar following. Which wave requires a medium, which is a gas, liquid, or solid? Which type of wave requires a medium? Okay, we got red mechanical, blue electromagnetic. No worries, Dolly. Siva, make sure I get your answers in the chat box. Appreciate it, guys. What's the date today? The 12th. It's my daughter's birthday. I know that. It's okay. Just do your best. She just turned 1 today, Dolly. Yes, this is a mechanical wave. Mechanical. A lot of times when you think of mechanical, you might think of like a machine. And so machines are very physical, right? So this requires something that's physical, a gas, liquid, or solid. Electromagnetic waves don't, right? So let's make sure, awesome, we've got Libby in the lead. Let's make sure that this makes sense. All right, I'm going to go ahead and put this on the whiteboard, right? So mechanical waves require a medium. Electromagnetic waves like sunlight don't, so they can travel through space. And all waves, whether mechanical or electromagnetic, transfer energy. That is the purpose of waves. Let me know if that makes sense. Red, yes. Blue, not yet. Yellow, sort of. Go ahead. Get that up there. Looking good. Love it. Okay, here we go. Identify the amplitude. Which one of these is the amplitude? Which one of these is the amplitude? This is kind of a tricky one. Notice B and D are actually different things, so do keep that in mind. B and D are actually different things. Be careful. Awesome. Dolly, I see your answer. Siva, make sure I get yours. 3 seconds. All right, letter D was actually the correct answer. So letter D right here, from the rest to the crest, is the amplitude. You could also measure from the rest to the trough. All right. Libby still holding on to the lead. Identify the wavelength. Go ahead and identify the wavelength now. Which one is going to be the wavelength? We can probably guess not D because we just learned letter D is the amplitude, right? So you actually have a 1 in 3 chance now. 1 in 3 chance to get this right. Awesome. Dolly, I see your answer. Siva, make sure I get yours. Yes, letter A is actually the wavelength, right? So from crest to crest, the length of a single cycle where it repeats, that is a wavelength. Awesome. What is B called? Oh, sorry, actually, no, that might be my next question. Let me double check. The highest point of a wave is called the highest point of a wave is called the what? The highest point of a wave is called the what? Oh no, Brianna. It's okay. You can do a comeback. Don't even worry. Sally is catching up to Edgar. Sally is just throwing out that challenge. Highest point of a wave, what's that called? Get your answer in there. Red trough, blue crest, yellow equilibrium. Oh no, Kim. It's okay. The game can still turn around. We still got a lot of questions left. Yes, this is going to be called the crest. The crest. All right, so let's make sure that this makes sense. Okay, I do have an image up here, right? So the highest point is called the crest. Lowest point is called the trough. The distance or the height from rest to crest is called the amplitude. Could also be rest to trough, right? Because this is symmetrical. And the wavelength is the length between two similar points. So between crest and crest, trough and trough, or even, right, the two humps, right? Going up on the equilibrium, going up on the equilibrium. Oh no, Adrian. The other people are just getting it faster. All right, guys, let's keep on going. Livy still in the lead. Livy is doing awesome with the little snake. I love it. What is the frequency of this wave? What is the frequency of this wave? Okay, so we've got 20 waves in 1 second, or one wave is 0.05 seconds. Which of them is the frequency? Frequency. No worries, Zoe. We are in Kahoot, right? So go to kahoot.it, enter the pin, and go ahead and answer that. Yes, it's actually going to be 20 hertz. Remember, frequency is the number of waves in a second. So frequency should always be hertz or waves per second, right? Period is going to be the period of time. So time, seconds, 0.05 seconds, that would be the period. Awesome, guys. Let's make sure that that makes sense. Make sure that makes sense. So period, time for a single wave, right? So that would be just one itty bitty wave. Frequency is actually the number of cycles in a whole second, right? So 3 cycles in a whole second, or 3 hertz would be the frequency in this picture. Let's make sure that that makes sense. Tell me yes, yellow, blue sort of, red not yet. Let me know how we're feeling. Oh yeah, live rats can definitely be a little bit dangerous for some snakes, right? Because they can be a little bit scratchy. Oh no, Ariana. Okay, don't worry. I can tell you what's on the screen. Okay, so if it still stays frozen, let me know. Cool. All right. Livy in the 7,000s. Oh my gosh, somebody's got to catch up to Livy. If these are sound waves, which one has the highest pitch? Highest pitch. Pink, that's the bottom one. Red is the top one, and green is the middle one. Okay, it's good. Awesome, Ariana. I didn't know how I was going to explain this picture, so I'm glad you can see the picture. Awesome, Dolly. I see yours. Siva, make sure I see your answer. Oh, I didn't know that. That's good to know. Cool. The older they are, they can handle live ones. I like it. I like it, learning that. Cool. Oh no, Livy. Yes, the bottom one, the pink one, actually has the highest pitch. Because remember, pitch is related to what? Pitch is related to what? High pitch also means high what? Tell me in the chat box. High pitch also means high what? No, not quite wave. It's one of the characteristics of a wave. Yes, it also means high frequency, right? So this one is the highest frequency because it has the most waves in its part, right? It has more waves in its little bit, right? In its amount of time that it has to travel. So higher frequency also means higher pitch. Okay, so let's make sure 4 players hit an answer streak. Edgar took the lead because Livy accidentally got that one wrong. No worries, Livy. You can make a comeback. All right, let's make sure that this makes sense, right? High pitched, high frequency, and that's going to be more waves, right? So a whistle will have more waves in an amount of time to make it higher pitched. Low pitch, low frequency, like a guitar. Less waves in a second. Awesome. Red, not yet. Blue, yes. Yellow, sort of. 10 seconds. Get your answers in there. Awesome. Thank you, Siva. Thank you, Zoe. Dolly, make sure you're answering. Let me know if that makes sense. Perfect. Looking good. All right, Edgar in the lead. Let's see if anyone can take the lead from Edgar. Sound travels fastest in which type of medium? Liquid, solid, gas, or it does not depend on medium? Sound travels fastest in which type of medium? Remember the guy with the cool accent and the dominoes and the balloon, right? That was that demo of how sound travels in different types of mediums. Awesome. Got an answer from Siva. Got an answer from Zoe. Dolly, I think I see yours, right? I think I see yours. No, it actually travels the fastest in solids. All right, Vega in the lead. Combo breaker, 3 players is, oh no, this was a hard one. No worries, guys. Let's review this. I know this is a hard one. Remember that we talked about how the closer molecules are, the faster sound can travel. It's like playing telephone. You can play telephone faster when someone is right next to you as opposed to across from the room from you. So we can travel it faster in water than in air, but we can actually travel the fastest in solids. Right? Let me know if that makes sense. Awesome. Yep. So let's make sure that that makes sense, right? We can travel, sound travels faster in water, which is why organisms can travel much longer distances. But for example, in steel, it actually travels 20 times faster than in air. It's crazy fast, like 5,000 meters per second as opposed to 340 meters per second. It's much, much faster. Cool. All right, looking good. Vega in the lead. Let's go ahead and see what happens now. The phenomena in which planes traveling faster than the speed of sound is called what? Yes, exactly, Sienna. That's how we learn. We get it better next time. I like the attitude. That's what we should be thinking. 15 seconds. Yes, Kim. Right, we saw an awesome video, all of these planes. What was that called? Go ahead, answer on your Kahoot. Yes, this is the sonic boom. Sonic boom. That was what that was called. Because remember, we saw that the sound waves build up because they can't catch up to the plane. And then when all that energy is released, it goes boom. Right, Johnny? All right, Vega holding on. Does this make sense? Let's make sure this makes sense, right? So airplanes traveling faster, the sound builds up in those cones behind the... It's okay, Kim. We still got like, what, 8 questions left? It's still possible. It might still happen. Oh no, Zoe. Okay, just do your best, Zoe. I know that you're participating, so it's totally fine. Just keep on doing your best. Love it. Looking good. Okay, compressions in sound waves are areas of low pressure, red, or areas of high pressure, blue. Compressions in sound waves, are those the high pressure areas or the low pressure areas? What do we think? What do we think? Awesome, Zoe. I see yours. Dolly Siva, make sure I see yours as well. Yes, Adrian, sometimes you just got to guess. Yes, it's going to be areas of high pressure. Areas of high pressure. 3 players on an answer streak. Let's make sure that this makes sense. Right, so we learned 2 terms for sound waves. Compressions are the high pressure areas, and rarefactions are the low pressure areas, right, where there's less molecules, and it also, when we graph it, it's the trough of the graph. Compressions are the crest of the graph, rarefactions are the trough of the graph. Looking good. Make sure you let me know if that makes sense. Looking hard. Perfect. All right, let's keep on going. Question 18, if an ambulance is moving away from you, its pitch is what? If it moves away from you, it's already past you, moving away from you. What is its pitch? Higher, lower, or the same? Yeah, exactly, Haley. It's always fun to do these challenges. Yes, it's actually lower as it comes towards you. Lower as it comes towards you. Sienna, back in the game. Love it. Let's make sure that this makes sense. Libby climbing back up. Right, so as it moves away from you, remember those waves are slow, so they spread out. And because they're spreading out, that means low frequency and low pitch. It sounds lower as it passes you. Let me know if that makes sense. Red is not yet, blue is yes, and yellow is sort of. Oh, just 2 points, Adrian. Oh my gosh. The competition is fierce. 5 seconds. Perfect. Glad that's making sense. Let me just double check, guys. All right, so again, as an ambulance moves away from you, remember the sound waves can't catch up to the ambulance. So the sound waves all spread out. And as they spread out, that means that we have a low frequency. And frequency is related to pitch, right? Low frequency, you hear a low pitch, like more like a male's voice. Okay? On the other hand, as it comes towards you, they all get squished together, which makes a very high frequency, right? All the waves are stuck together, high frequency, also a high pitch. Smiley faces if this makes sense, guys. Okay, just because I had a couple of people who said that didn't make sense, I want to slow down, make sure we understand that. That is what we reviewed today, so I know it's very fresh in our brains. 8 players on a streak. Vega still in the lead. Sound is an example of a transverse wave, surface wave, or longitudinal wave. Remember, what pattern do its molecules do? Up, down, circular, left, right, transverse, surface, or longitudinal? Yes, Kahoots are lots of fun, right? It'd be fun to find another game as well. I feel like it'd be nice to mix it up, but I haven't quite found another game that is just quite as engaging as this one. There's not a lot of options online, unfortunately. Yes, this one is actually going to be a longitudinal wave, longitudinal. And the reason for that is because, remember, these molecules actually wiggle left and right, which is parallel to where the energy is going, which is from the left to the right. Smiley faces if that makes sense for longitudinal. Longitudinal is because the molecules go along with the energy, Awesome. So, Michael are back in the game with an answer streak. This is an example of a, take a look at this. This is an example of what? Longitudinal, surface, or transverse. This picture that I've got up here of a molecule moving in a circle, what is that? Livy is trying to reclaim the first place from Vega. Kim hanging on. Awesome, Zoe, I see your answer. Dolly. Oh, sorry, Zoe, I don't think you've given me an answer for this one yet. Zoe, Dolly, and Siva, make sure I'm getting your answers. Yes, this one is actually a surface wave, So let's make sure this makes sense. Oh my gosh, Libby is seriously catching up. So taking a look at this, we got 3 questions left, right? So longitudinal, the particles move parallel, left and right. Surface wave, they actually move in a circle because they are mixing parallel and perpendicular. Transverse waves are the perpendicular ones. They move up and down like a stadium wave. Let me know if that makes sense. Awesome. Thank you, Siva. Dolly, make sure I see yours. Zoe, make sure I see yours. Siva, make sure you're answering the actual questions as well, not just the yes, sort of, and not yet. Let's make sure that makes sense. Awesome. Looking good. All right, so 6 players on a 5 answer streak. This is an example of constructive interference or destructive interference. If we put these 2 waves together and this is the result, is that constructive or destructive? Siva, make sure you answer this one. Okay, Dolly, make sure I get yours, and Zoe, yours as well. All right, looking good, looking good. All right, this one is going to be constructive interference. So let's make sure that this makes sense, guys. So taking a look at this, right? Constructive interference is when the amplitudes are line up and therefore they add up and the wave doubles in size, right? Constructive, think about the word building up. Destructive interference, on the other hand, is destructive and it goes ahead and it destroys the wave because the waves are opposites. So when those opposites meet, they cancel out. Let me know if that makes sense. Perfect, looking good. All right, Vega is the top scorer. All right, I'm going to go ahead get our results here. So Vega on a nice answer streak in the lead. Livy came back at least to get 2nd place. Kim in 3rd, Edgar in 4th, and Grant in 5th. Go ahead, give your classmates a round of applause. You guys did wonderful with that. I'm going to go ahead and save those results really quickly. Give me a moment to do that. And then I'm going to go ahead and wrap us up. And we get to end a little bit early today. Smiley faces if that makes you happy. Let's see here. Saving this. Kahoots, what's the date today? The 12th. I know today is the 12th for the 12 p.m. class. Cool. All right, guys, let me go ahead and finish up here. So your last word of the day is Doppler. That is what you should put in your attendance ticket. Go ahead and submit that and say your goodbyes. I'll see you guys all next week. Have a wonderful weekend. Bye, Ariana.